Hello class, this is a video tutorial on probability theory. The three concepts that we will be using at this level of math are the sum of probabilities, complementary events or complementary probability, and expected frequency. The sum of probabilities in any chance experiment must equal 1. So for example, if we say that a bag contains only red, blue, and green balls, the probability of picking red is 2 out of 5. The probability of picking blue is 1 in 4. What is the probability of picking green? And what is the smallest number of balls in the bag? Well, since all the outcomes are red, blue, or green, that must mean the probability of red plus the probability of blue and the probability of green. If we take each probability, they must equal 1 or 100%. Well, the probability of red is said to be 2 out of 5. The probability of blue is 1 in 4. And we don't know what the probability of green is. Well, we do know it must add up to 1. Well, using our calculator, 2 out of 5 plus 1 out of 4. That becomes 13 out of 20 plus the probability of green equals 1. Working this like algebra, we can subtract both sides by 13 out of 20. So 1 minus our answer here. That gives us the probability of green being 7 out of 20. So the probability of green is a 7 out of 20. And as you can see, the denominator here is 20, and that's the simplest form. So the fewest number of balls in this bag, fewest number balls in bag equals 20. So that is the sum of probabilities. And the idea about that is that each outcome, if we take all the outcomes, add them, they must equal 1. Just using algebra, we can figure out what the missing probabilities are. Complementary events or probability lists or calculates the outcomes not in a specified event. In math notation, complementary events are written as, so if you're given the event E, the complement to E is E with a little dash on it. Or you might see it as E with a bar on top, or E with a C on top of it. So for example, in a 100-meter race, the contestants are Alfred, Byron, Charles, David, and Edgar. A sports club will win if Byron or David come first. What's the probability the club loses? Well, let's write this down like so. The probability of a win, so let's see W for the win. The sports club winning relies on Byron winning or David winning. So these are the two outcomes that will result in the event of a win. The complement of a win is a loss. You could just say L for loss, but I'll use the proper notation, W dash. Well, for complements, we list all the outcomes that are not in the event. Well, we remove Byron, remove David, and the remaining names belong in the complementary event. This is Alfred, Whoops. Alfred, Charles, and Edgar. Let's put Ed. So now, hope we can see that the probability of a win is 2 out of 5, and the probability of not winning is a 3 out of 5. And I hope this actually also points out how this combines with the sum of probabilities, in that the probability of E plus the probability of not E must be 1. And we can see that here. So the probability of winning is 2 out of 5. The probability of losing is 3 out of 5. If we add these two, 2 out of 5 plus 3 out of 5, we get a total of 1, which is 5 out of 5. I'll make this one purple because it's a very important thing that we use pretty frequently at this level. Here's another example. The probability of the event Q occurring is 0.12. What's the probability? It doesn't happen. Well, as I just pointed out up here, it says that the probability of Q plus the probability of not Q, of Q not happening, must be 1. Well, we know that the probability of Q is 0.12. Probability of not Q is 1. Well, subtracting both sides by 0.12, we get the probability of not Q is, let's just calculator for this, 1 minus 0.12, in a decimal, 0.88. So the probability of not Q is 0.88. One last one. Expected frequency. Expected frequency estimates the number of times an event E will occur if an experiment is repeated n number of times. Expected frequency is calculated as, I write it as EF, expected frequency, equals the probability of E times the number of repetitions of that experiment. So for example, how many tails would occur in 1,000 coin throws? Well, the expected frequency, it's how many times you would expect it to happen, equals the probability of tails times the 1,000 trials, or the 1,000 coin throws. Well, tails, the probability of tails on a coin throw is half times 1,000. You put that straight into a calculator, but it's going to be 500 tails. So that's the expected frequency of tails in 1,000 coin throws. Let's do another one here. A bag contains 1 red, 2 blue, and 3 yellow balls. If a ball is randomly selected and returned 30 times, how many of those times would show red? It's saying now, what's the expected frequency of red if the probability of red, and we repeat it 30 times? Well, for the probability of red, it's 1 out of, adding these up, 1 plus 2 is 3, 3 plus 3 is 6, so there's a 1 in 6 chance that red is selected, times the 30 repetitions. 1 in 6 times 30 is 5 red. So that puts us to the end for the 3 concepts that we'll be using: sum of probabilities, complementary events or probabilities, and expected frequency. So, hope to see you in the next video. Best of luck.